pure translation. And pure rotation. So we assume the body gets a translation, and that reference point is center of mass. So this was the initial configuration. Now it is like this. So there is also a rotation undergone by the body. So initially a coordinate system was like this. Now it is like this. So any particle here has same position with respect to the embedded coordinate system. Now this is my original particle, call it capital X. This is my new position, call it small x. So the body has gone from here to here, and we want to see what is the motion, what is the displacement of this particle capital X. We say angular velocity of the body is equal to omega. The initial position of the particle was x bar. It has gone to small x bar. This is your initial origin, this is your current origin. We have a fixed coordinate system like this. This is our fixed coordinate system. Now initial position vector of the particle of the center of mass is capital O. This is our initial coordinates, initial position vector of the coordinate system which is embedded. And the final position vector is so what is the translation of the origin? So you can say vector displacement
Rho dash O bar.
origin. Okay. Now initially with respect to the rotated coordinate system, so our initial so what is the displacement of the particle? This was our original position of the particle after translation. So this position becomes like this. because of the rotation. What is this delta R? Because of pure rotation. Any problem with this? We have discussed something similar before. Hello, good morning, sir. कल आ जाओ कल कल सर मुझे मैं उससे बात करूँगा सर एक आईआईटी दिल्ली का स्टूडेंट है उसकी कोई भी कोई चीज़ें का टॉपिक की वही का वही क्या था वो समझाए तो दिखता ही नहीं देगा छोटा चलो फिर से तो मेरी बात स्टूडेंट का पूरा 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 ये तो ऐसा लगा बिल्कुल नीट कुछ ऊपर का कुछ नहीं पता तो मैं इसे देख रहे थे क्या Okay, so we will again see the how the initial configuration of the body, final configuration. And this was our center of mass. And this is our pure translation case. Body moves from this position to this position by the displacement vector corresponding to center of mass. So we had the original point capital X here. So this is that capital X before rotation. After rotation, it is here, small x. And this displacement vector is given by delta theta cross O prime capital X. This is our O. This is our fixed coordinate system. So what is the position vector of point X? This is nothing but position of the origin plus, you can say like this, do you agree with this? Hello, Shubham, roll number 61. Are you guys there?
Yes, sir. Yes, sir.
So final position vector of the particle is equal to, now I am seeing capital X here. So this is with respect to the your embedded coordinate system. So this capital X is same whether it is you are measuring from here or you are measuring from here. So this small x I am measuring, for example, from the fixed coordinate system. Let's call it E1, E2. So these are from the embedded coordinate system. Let's call it small E1, small E2. So with respect to the embedded coordinate system, we have got this. This is capital O prime is from the capital, and this is from your embedded. Now what do you say? Do you get the final position vector of the particle?
सर ये कैपिटल एक्स जो स्मॉल एक्स है सर इसमें भी तो सर कैपिटल वाला आएगा E1 E2 E3.
Okay, let's see. Now my small x I have taken from this point. Okay. Now what is this equal to? I say this O prime from the fixed system. Okay. Plus capital X. This is from the small system, embedded system. This I am measuring in the embedded system. Plus this again is in the embedded system. Any doubts?
No sir, clear.
Now this you can calculate by delta theta cross okay. So because of operation of pure rotation, now what is my displacement? Now you look at this capital X from capital system. What is this? This is origin from capital system plus capital X from small system. Do you agree? This was my initial point, initial position of the particle. So this I am measuring from the fixed coordinate system. First origin of the fixed coordinate system, origin position vector of this E1, E2, E3 with respect to capital E system plus position vector of capital X with respect to this small E1, E2, E3 system. Is there any doubt? Lavish.
नो सर सर मुझे सर ये वाला समझ नहीं आ रहा है कि सर ये लाइक जो कैपिटल E1 E2 है ये सर इस प्लेन में है और सर जो स्मॉल E1 E2 ले रहे हैं सर ये हम कौन से फ्रेम में ले रहे हैं सर रोटेटेड वाले फ्रेम में ले रहे हैं या फिर सर जो नॉर्मल प्लेन है इसी में ले रहे हैं
This is embedded. It will rotate with the body.
So E1 E2 also rotate with the body.
Okay, you are not too wrong. For the time being, you assume that it is traveling with the body. Okay. So now it will look like that there is a problem here. If it is rotating with the body, then X and capital X become same. If it is measured with respect to, you assume this is just translating with the body. Okay. Is it all right? Even E2 is translating with the origin. It has not kind of rotated. Is it okay? Then you can use this relationship here. This change you are seeing is delta theta cross this. Any doubt? So let's see, we proceed further, then we'll see what is happening. So we want displacement of the particle. You can find displacement only if it is measured from one fixed coordinate system. So you get x bar minus capital X bar. So this is your displacement. Any doubt? Now you see we have got O bar and O prime. So O prime minus O. The entire thing is measured with respect to E1, E2, E3. Now you see this X bar and this X bar are same. They are not going to change. So they will cancel out. So what is left is delta theta cross X bar. Any problem? So this you can say is your, let's call it displacement. Yes, Lavish.
सर ये O minus O dash होना चाहिए था
Okay, okay. O prime minus O. Okay. I have subtracted this fellow from this fellow. So O prime minus O. So this is what it is. So this refers to the translation part. This refers to the rotation part. This is translation of centroid. This is rotation of body. About axis passing through centroid. Now if you want to find velocity, you have to take derivative with, you have to divide by delta t. This displacement has occurred over time delta t. So you will get velocity of the center of mass. You can replace x bar by small r bar. R bar is position vector of particle. With respect to embedded coordinate system. Is it all right? So you have got absolute velocity of the particle. So this is absolute velocity of the particle. Because you have measured it with respect to fixed coordinate system. So this is known as splitting. You have split the general rigid body motion into two parts. Pure translation. You translate the body with the displacement of the center of mass, and a pure rotation about an axis passing through center of mass. So there is a delta t you have to divide. So this becomes so you get velocity of any particle. Is it all right? So you have a body. You got different particles. You have their velocity now. So if you say velocity of particle I, so you replace r with ri. Okay. So you get velocity of particle I. Suppose you want to find kinetic energy of the body. So you will sum it up over all the particles. So this will be equal to half mi vi. You have to sum over all the particles, whatever they are, or it is a kind of an integration. Is it all right? Now what you will do? What is your vi? You use this thing. If you are not happy with anything, you can raise your voice. So This is a dot product. So V center of mass dot V center of mass. So it becomes velocity of the center mass square. So you're taking a dot product with this and omega cross Ri. Similarly, you will do omega cross Ri dot VCM. So it means this becomes twice of it. Plus now how do you handle it? Any vector result you know which can help you in simplifying it? Any ideas?
सर जो ये सेकंड वाला है इसमें से हम ओमेगा को कॉमन ले लें, लाइक फिर ओमेगा क्रॉस आर आई डॉट आर आई इस टाइप का बन जाएगा.
Think out how you can simplify. Okay, let's see what we can do. So if we pick one term, 2 V center of mass dot omega cross I take it inside. Any problem with this? Yes. This Mi is multiplying everywhere. So I have brought it to this term. And it's a scalar quantity. I have multiplied with vector Ri. Now what is this MIRI? It is a summation. You see, you have to sum it up. So you can carry the summation here. Because these terms don't depend on the particle. So what is the value of this sigma MIRI? Anybody?
Some moment of inertia.
This is first movement of mass. First movement of inertia. What is first movement of inertia? What does it give you? Does it give you the position of centroid? How do you get centroid? Look, what do you do for centroid? You have a particle mi. You know its position vector ri bar. So you sum it up over all the particles, and then you divide it by total mass. That you say is the position of your center of mass. This is the way you have been finding center of mass.
Yes, sir.
So now our origin is at center of mass. Our origin is at centroid. So what is the value of this? Will it not be 0? It is giving position of center of mass. And center of mass is 0 because our coordinate system is at the centroid. Is it okay? You see, these were all position vectors with respect to embedded system. So this is the velocity with respect to the center of mass, omega cross Ri. So these are the relative velocity with respect to center of mass. So now this becomes 0. So this term goes away. So what you are left is this term. So now you have got term mi omega cross Ri dot omega cross Ri. Is there any shortcut for this? Yes. Do you know any shortcut for this? Okay. So let's talk about any two vectors A cross B. What is the cross product? If you take its magnitude, now what is its dot product? So if you take a square of this and a square of this, what will you get if you add them up? Can you see what has happened? So can you say that A cross B dot A cross B is equal to can you say that? Yes.
Yes, sir.
So can I write it like this? Can I write like this? Instead of A and B, I am having omega and R. Yes.
Okay, sir.
what is omega dot Ri? That is a simple question. Can I say it is what is my vector Ri? I say Ri is x1, x2, x3, and omega is omega 1, omega 2, omega 3. It has got three components. I am just taking a dot product. Okay, now let's see how we can write it in a simple manner. Okay, let us. Now we have got omega square r square another term. Can I write omega square as omega I, omega I? Do you agree with this?
Yes, sir.
What does it mean, omega I, omega I?
Omega 1 into omega 2, omega
No,
1.
no, no. You have a vector omega. It has got components omega 1, omega 2, omega 3. What is its magnitude?
Sir, root of omega 1 square plus omega 2 square plus omega 3 square.
So this I can write as omega I into omega I. I had told you about Einstein's notation. So I is a repeating index here. So it will take all the three values 1, 2, 3. First to make it 1, you get omega 1 square, then 2, then 3. Is it alright now?
Yes, sir.
No, you can do the entire thing by a long hand and you will reach the same result. I am just trying a shorthand. Okay. So omega square is this. And what is your r square? Can you do something similar? Can I say it is xk xk?
Yes, sir.
Vector r is what? x1, x2, x3. So what is r square? x1 square plus x2 square plus x3 square. So I can use, instead of this, I can say xk xk. All right. So I get omega square r square as omega I xk xk. Is there still any problem with this?
No, sir.
Do we have to multiply with something else also? So I takes all the values 1, 2, 3. A takes all the values 1, 2, 3. Here got 1, 1, 2, 3, 3. So this fellow will also do the same thing. Okay, what we do further? Now pick the other term. Omega dot Ri. So you need a square of it. What is this dot product? Can you write it as omega 1 x1 plus omega 2 x2 plus omega 3 x3 plus square. So can you write it as omega I xi? How will you square it up? So let's write suppose omega k xk. So you have got this quantity and this quantity. Both mean omega 1 x1 plus omega 2 x2 plus omega 3 x3 individually. Now what you are left with? So you have to do omega square r square minus omega dot ri. So what it is equal to omega I xk minus omega I xi omega k xk. Is it all right? Now can I do a trick? I multiply with omega I, omega k, delta ki. Is it all right? What is delta Ki? I had told you delta Ki is Kronecker delta. It is equal to 1 if K is equal to I, is equal to 0 if K is not equal to I. So this is known as Kronecker delta. So now omega I, omega K is there in both the terms. You take it outside. You are left with xk delta Ki minus xi. Any problem? Now you had you were having you are finding kinetic energy. So there is a factor of half mi. So your total kinetic energy is half mi VCM square. It's a summation over all particles plus half mi. Now you are having these terms. So this you have to integrate or add over all the particles. So what does it mean? What does it give you? So instead of m, you can call it dm. Can you call it dm? You have taken a particle of mass dm, and this is angular velocity of the body. This is component I, component k. This is your position vector r square. Xk is take any position. You are measuring from the center of mass. So this is your r square. Xk. And these are your coordinates I, xi, xk. So this you will see sigma half. Now VCM is common, so you can replace it by half m. This becomes total mass of the body. The velocity of center of mass is same for the entire body. So this will give you just total mass into. So this becomes your translational kinetic energy of the center of mass or of the body. Plus now this is other term. So you can say you can define a parameter half so what is this IIK? So this is nothing but so this your doing over the entire mass. Can you see this? Now what I will do is I just calculate some of these terms. Ixx. This is nothing but this matrix. Ixy, Ixz, I Ix, Iyy, Iyz. So you've seen, did I tell you about the stress tensor? So this is inertia tensor. So Lavish, are you following?
Yes, sir.
Okay. So I just see how you calculate this Ixx. We'll take a simple case. You have already seen this problem. This is your bar. Now you want to find, suppose I say Ixx. Now let's take a different one. You just take a rod, angle theta. Length of the rod is L, mass is M. This is my X, Y, Z. Suppose my rod was like this. This was my X axis, Y axis, Z axis. So what is its I axis, Lavish?
What, sir?
Ixx. Suppose this is a thin rod. This is a thin rod. What is its Ixx?
Sir, the distance traveled from origin to
Okay, let us see what is my expression of Ixx from here. Instead of I write X. Instead of K, I write X. So XKK, this is basically nothing but x square plus y square plus z square. Now Ixx. So K and I are basically instead of K, I should write here something different. XM. So there is no confusion. Suppose I write like this, because this I know this is r square. So this is nothing but x square plus y square plus z square delta ki. Now both k and I are xx. So this will be 1 minus, both are x. So here you will have I is 1, k is 1. So this is basically nothing but I11. So this is nothing but I11. So you get x square dm. This you have to integrate. Can you see this, Lavish?
yes, sir.
So this is nothing but your r square minus x square. Sorry, what is the physical meaning of this? Can you tell the physical meaning of this? What is r square minus x square? Suppose you are having a point here. This distance is r square. So this distance is x square. So what will be, this distance is x, this distance is r. What is this distance?
Sir, root of r square minus x square.
So what will you call this distance physically? Distance of the point from x-axis. Can you say that?
Yes, sir.
So this is the distance of the point from x-axis. So r square minus x-axis. So I-axis shows it is a kind of a term which tells how points are away from the x-axis. So it is taking distance square of the points from x-axis. So now if your rod is a thin line, it's a thin rod. What is the distance from x-axis of all the particles on the rod? Yes, thin rod means you are neglecting the y dimension. 0. Is it not 0? Suppose you have a line like this, lying on the x-axis. Different points on the line. What is the distance from x-axis? Yes.
सर
Zero?
नेग्लेक्टेड एकदम सर जीरो नहीं कह सकते सर
Why?
बिकॉज सर अगर मल्टीप्लिकेशन में देखें तो वो कुछ टर्म देगा बट हम एग्जैक्ट जीरो नहीं कह
Take
सकते
any point on the line. What is the distance from x-axis? You draw a perpendicular to axis.
जीरो सर टेंड्स टू जीरो कह सकते हैं
It is 0. What tends to 0? The line is lying on the x-axis. So
Yes,
its distance from x-axis is 0. Take any point on the line. Its distance from that x-axis is 0. Okay.
less than zero
So I am taking it as a thin rod. So I say its distance from x-axis is 0. So what I will get? I-x-axis will be 0. Now I take its distance from y-axis. Take any point. What is the distance from y-axis? Yes.
Under root r square minus y square.
What is y coordinate? Suppose the line is lying on x-axis. Y coordinate is 0. Your z coordinate is also 0. So basically your distance from y-axis is just x.
Yes, sir.
Okay. So now what is your I-y-y? So you take an element of length mass dm at distance x. So you have to take x square because you are dealing with squares. You integrate and you have to take the integral from 0 to L. So what are you getting? X cube by 3.
yes sir so then this will
So
L cube by 3
what you do instead of dm, what you can use? Rho dx, because you're integrating with respect to x. You assume your rod has a linear density rho. You understand linear density?
Yes, sir. Mass per unit length.
Yeah. So what will be the mass of that element? Rho dx. So you will get rho x cube by 3. Now what is rho into, if you take the limit 0 to L? So rho L cube by 3. So what is rho into L? Mass of the rod. So you get ml square by 3 as the answer. You see now you are taking it about the end. If you had taken about the midpoint, you have to add plus m L by 2 whole square. This you have read in I think 12th standard. So you will get ml square 1 by 3 plus 1 by 4. What is this equal to?
Sir, 7/12.
Something has gone wrong. Is it? You are expecting an answer ml square by 12.
सर माइनस होगा ना फिर.
Oh yeah. So we have to use a minus sign. Okay. So I have slightly messed it up. Okay. So you get 12, 1 by 12. So whenever you take on the shifted side, then you add it up. Since you are finding about the centroid, you have to subtract. Okay.
Yes, sir.
So I showed you how you get Ixx, Iyy. Now suppose I want to find Izz. What will I get? What will be Izz? What is the distance of any particle from z-axis? Yes. Yes, can you tell me what is the distance of this particle from z-axis? You had already
Sir, 0 ही होगा.
r square minus z square. So you will find it is only x square because y and z both are 0.
Yes, sir. X ही distance होगा.
So you will get Izz as the same answer.
Yes, sir.
Yes,
Izz
sir.
is equal to Iyy.
Because you are having only x square dm. Again, you also know this theorem Izz is equal to Iyy plus Ixx. This is 0.
Yes, sir.
So both of them have to be same. So this is what you had already done in 12th standard. Now I will take one more simple case. This is your rod now at an angle theta. So what is your Ixx now? Take any particle. Suppose you are taking the position r. What is the distance of this particle from x-axis?
R sin theta.
Very good. Can you say this, what I have written?
Yes, sir.
So your answer will be is it all right? Earlier it was mr square by 3. Now it is ml square.
बस R को सर R sin theta से replace किया.
ml square sin square theta by 3. Sin theta is a constant here. You can take it out of the integral sign. And this length is L. All right. So only different factor will be sin square theta. What is your Iyy?
Sir cos square theta हो जाएगा.
Sir, ml square cos square theta.
And what is your Izz?
Sir ml square by 3.
Okay. Look, its distance from z-axis will be always r. You have any point, so its distance from z-axis will be this distance r. So you're just integrating rho r square dr. What you will get? Rho r cube by 3, 0 to L. So this will be nothing but ml square by 3. And also you see Ixs plus Iy is equal to Izz. So you have to get ml square by 3. Is it all right?
Yes, sir, fine.
Your rod is in xy plane. Okay. So I told you how you can calculate different terms of the moment of inertia tensor. Now we will also calculate Ixy. What is our Ixy? Now you go to that formula which we found earlier. Look at this. What is Ixy? Now you see one is x, another is y. Xy. So what is delta, Kronecker delta in this case? I told you if two indices are different, Kronecker delta gives you zero value. So you get a zero value from here. So you will be just getting minus xy dx. Is it all right?
Yes, sir.
So these are known as product moment of inertia. So you get minus xy dx. So you have to integrate over the entire mass. So this is your rod. You take a point here. So you take a position vector r, sorry, an element at a distance r from the origin. So what is your x coordinate? This is theta. X coordinate is r cos theta. Y coordinate is r sin theta. So what is your minus xy dm? So you get r square cos theta sin theta. What is your dm? Rho dr. So you have to integrate from 0 to L. Can you see this integration? So what you will get? Minus ml square by 3 cos theta sin theta. All right. If I want to find Ixz, what it will be? Anybody? Can you get? You can directly get the answer without integration. That is the hint I am giving. Basically, it is minus xz dm. What is z coordinate of the points on the rod?
R, yes, sir.
Z coordinate is 0 because the rod lies in xy plane.
Yes, sir. 0 है.
It's a thin rod. So you get a 0. What will be Iyz?
So वो
0.
Very good. So what is the moment of inertia tensor for this case? ml square by 3 you take outside. Ixx was sine square theta. This was cos square theta. This was 1. What was your Ixy? So this is a symmetric matrix. Ixy is equal to Iyx. So you get this, you understand this moment of inertia tensor? Any doubts? Have you heard of principal axis? Hello?
Sir, this was the axis through which we are assuming like origin is placed at there.
Like principal axis you must have heard in when you dealt with moment of inertia. Principal movements of inertia. Like here you see this was your rod. If your coordinate system was like this, what would have been your movement of inertia tensor? Yes. You see x, this was your x axis, y. This would have been a 0. This would have been ml square by 3. This would have. And your product terms would have been all zeros. Because you see all points on this line have x equal, y equal to 0, z equal to 0. So all product movements will be 0, x, y, x, z, y, z. Can you see? So this is known as principal moment of inertia tensor. Any doubts?
Clear,
These
sir.
concepts will be repeated in when we will do stress analysis. That is why I am trying to do it properly here. If you follow it here, you will have less problems there. And this already you are aware of because you did it in 12th standard. Only you did not do it in this way. Okay. We have already done eigenvalue problems. Do you know what is an eigenvalue statement? What is an eigenvalue statement? Yes? Yes? Anybody? What is an eigenvalue statement? Yes, you are done in your first year.
So something like a minus lambda I is equal to 0, or like an
Very
x
good.
for a matrix.
So I'll just again repeat it for you. You have heard of a linear transformation, y is equal to ax. A is a matrix, x is a vector, y is a vector. If you say this is equal to lambda x, then this is an eigenvalue statement. So what is the meaning of this? You have a matrix. Suppose you have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. You multiply it as a vector 1, 0, 0. What will you get? Yes, anybody can calculate it. It will be your
So
first
it's a
column.
matrix of 1, 4, 7.
Yeah, first column you will get. Now what happened? Your initial vector was this. 1, 0, 0 is this vector. Do you agree?
Yes, sir.
So what is now the new vector? 1, 4, 7. So you have another vector 1, 4, 7. Basically 0, 0, 0 is joined with the point 1, 4, 7. You will get this vector. Now what is the difference between these two vectors? Yes, what is the difference?
So which two vectors?
input and output. This is your input. This is your output. This is your transformation called linear transformation. So input was transformed into output using this transformation. So what is the difference between these two vectors? Can you say there is a change of magnitude? Magnitudes are
Yes,
different.
magnitude change.
And can you say the vector has rotated, changed direction?
Yes, sir. Only x is same. They are rotated in y and z direction.
No, no, it is a total change of angle. It is no longer the same direction. It's a different direction. Okay, it is a different unit vector now. अच्छा बल्ब लगा दिया ठीक ओके थैंक यू so you see this transformation has changed the magnitude as well as rotated the vector. So transformation A has changed the magnitude of input and direction also. Is it okay? Do you agree?
Yes, sir.
Okay. Now I will take a simple case which you have already seen. This is a moment of inertia tensor. Now I multiplied it with a vector. Suppose I take the vector what will I get?
So 0, 1, 0.
So I'll get the same answer.
Yes, sir.
So you see, now this answer has the same direction as the input. Suppose I had taken 1, 0, 0. What would I have got? All
So 0, 0,
zeros.
0.
So I will say the magnitude has become 0. So I can say same direction. 0 vector has any direction. Now suppose I take the vector as 0, 0, 1. Now what will I get? Output 0, 0, 1. So you see, there are certain directions here. Your output also has the same direction. So such directions are known as Eigen Directions or Eigen Vectors. Now we go to the actual matrix. So this was sin square theta, cos square theta, 1. This was minus sin theta cos theta, minus sin theta cos theta. What should I take here? So that I get the same direction as this input. Suppose I take 1, 0, 0. I'll get this column. So it is not the same direction. Can somebody suggest me a direction? Which will give me the same answer as that direction. Answer is there just before you. Just before you, I have done something. Suppose I take the direction as this direction. I showed you, had I taken this direction, I would not have got the same answer. Suppose I take direction 1, 0, 0. What do I get?
Sin square theta minus sin theta cos.
So this is definitely different from this. You cannot deny it. Suppose I take the direction as this direction. What is this direction? Yes? Can you tell me this direction? You must know this. Yes? Lavish?
Sir, 0, 0, 1.
No. With respect to this coordinate system. With respect to this coordinate system, what is this direction? Like you found this inertia tensor with respect to this coordinate system. So you will take the input vector in this coordinate system only. What is this coordinate? Suppose this is distance is 1. What is the coordinate of this point? This is just 10th standard stuff. What is the x coordinate? You apply trigonometry. Lavish. What is this distance? If this distance is 1, cos theta.
Yes, sir.
So this becomes cos theta sin theta 0. Suppose I multiply with this, what will I get? Now we should try sin square theta into cos minus sin square theta into cos.
Sir, then 0, 0, 0.
All zeros. Good.
Yes, sir.
Now suppose I take this direction. What is this direction? What is this vector? So I tell you this vector is cosine of 90 plus theta. What is that? Cosine of 90 plus theta minus sin theta. Sine of 90 plus theta. That is nothing but cos theta. And 0. Now you try. What will you get?
Sir, then फिर से sir 0, 0, 0.
No, it should not be. Let's see. Minus sine cube theta plus sine square theta cos theta. So what you are getting? Minus sine cube theta, then minus sine cos square theta. Is it all right? So what is this equal to? You take sine theta outside. Minus sine theta outside you take. So sine square theta plus cos square theta. 1. So you are getting minus sine theta. Okay. Now you try this one. Minus sine cos theta into minus sine theta. So you will get sine square theta cos theta. Then you try cos square theta plus cos cube theta. So you take out cos theta, then you will get sine square theta plus cos square theta. So you will have a cos theta. So you see, you are getting the same direction. Can you see this? Similarly, you try 0, 0, 1. what you will get 0, 0, 1? Your answer will be the third column. Again, you will get 0, 0, 1. So you found eigen directions. You found such vectors which do not get rotated by this matrix. So such directions are called eigen directions, or eigen, and those unit vectors are called eigenvectors. So suppose I have this matrix. How did you find eigenvalues? Anybody? How did you find eigenvalues? You subtracted minus lambda from the diagonal terms and found the determinant, equated it to 0. Is it all right?
Yes, sir.
Now, how do you expand it? 1 minus lambda into. Is it all right? So lambda is equal to 1, or you have to solve this equation. What do you get? Sin square theta, cos square theta, it will knock out this. Sin square theta into lambda minus lambda sin square theta minus lambda cos square theta plus cos square theta plus lambda square is equal to 0. So what do you get? Lambda square minus lambda is equal to 0 implies lambda into lambda minus 1 is equal to 0. So you have got two repeated roots. One is 0, one is all right. How will you find eigenvectors corresponding to these roots? Anybody? You try to revise your book on eigenvectors and eigenvalues. What do you get? So I do for lambda is equal to 0 first. So you have sin square theta minus sin theta cos square theta 1 . So you are finding eigenvector corresponding to lambda is equal to 0. So you multiply with the direction cosines n1, n2, n3. You want to find direction cosines of the vector which does not get rotated and whose magnitude becomes 0. What answer you are expecting? Cos theta, sin theta 0. Already you have done it. So let's solve it. This equation. Now you see I can directly see the third equation. n3 is equal to 0. So you got the third component. Now look at this first equation. n1 into sin square theta minus n2 into sin theta cos theta equal to 0. Do you need to solve the second equation also? Do you need to look at it? Lavish.
सर डायरेक्टली वहाँ से पता चल रहा है कि sin थीटा 0 है.
But do you think a second equation will give you something different?
No, sir.
Why?
Sir, because this was exact same as above. ऊपर वाली जो equations थी
But
वो.
any further logic?
सर अब सर हमें उसकी आइगन वैल्यू जो हमने लैम्डा लिया था सर हमें चेंज करके फिर ट्राई करना चाहिए.
Look, gentlemen, determinant of this matrix is 0. This is what you started from.
Yes, sir.
When is the determinant of a matrix 0? When two equations are same. Only then determinant will be 0. So you will find that equation corresponding to row 1 and row 2 are same. These are dependent set of equations. They are not independent equations. So that equation will not give you anything new. Otherwise, determinant of the matrix will not be 0. Okay? That is the basic reasoning behind it. Now we have got this equation. Now what is my n1? Sin square theta is equal to n2 sin theta cos theta. So what I get, n1 is equal to so you can say because sin theta is not equal to 0. You can divide now what can you do? So if you take n2 as sin theta, n1 will be cos theta. This is what you are expecting. Or you take n2 as 1. If you take n2 as 1, n1 is equal to what? Cos theta upon sin theta. Your n2 is 1. Your n3 is already 0. Now you want to do what? You want to find a unit vector. So what is the magnitude of this vector? Cos square theta upon sin square theta plus 1 under root. So this will be nothing but 1 upon sin theta. Alright. So what is your, how do you find your components of the unit vector? Cos theta upon sin theta. You have to divide by magnitude. Similarly, what is your n2? So you're getting the same answer as you expected. Any doubts, Lavish?
No, sir.
So you see, you have to know how to find eigenvectors. So now your problem is that other root is having the same lambda. Then how do you handle it? You have the case of repeated roots. So corresponding to this, you found 1, 0, 0. Sorry. This was your eigenvector. Corresponding to this, you found cos theta, sin theta, 0. Now for this, what you will find? You see, you can directly see to it that all eigenvectors are perpendicular to each other. That is one special thing. Eigenvectors are orthogonal. When linear transformation is symmetric. Your I inertia tensor was symmetric. You check out your mathematics books. So your eigenvalues are real and eigenvectors are orthogonal. So you have to find orthogonal. What is the perpendicular vector to this? Minus sin theta cos theta 0. So you have got two eigenvalues. So you got both the all the three eigenvectors you have got. Any questions? So I told you how to find kinetic energy of a rigid body. So that was equal to half mvcm square plus, let me go back a lot. See, we are here. So this was our, if you look at this matrix, this product, you can write it as can you write it like this?
Yes, sir.
So this is nothing but ik omega k, and this is nothing but omega I. So you are getting one vector from here, and this is having dot product with another vector I, omega. So this is nothing but omega dot can you see this?
Okay, sir.
Ik omega k. So this is nothing but it's a vector form. You see, there is a free index I, and this is omega I. So it's a vector omega, and dot is multiplying with the ith component of this vector. Do you know the name of this vector I omega? This is called angular momentum vector. The angular momentum of the rigid body is known as I omega. It is having dot product with angular velocity, and this is your kinetic energy of the body. Rotational kinetic energy. This is called rotational kinetic energy. And other term was translational kinetic energy. So what I have done is I found total kinetic energy of a rigid body. So it can be split as translational kinetic energy plus rotational kinetic energy. Any doubts?
Clear, sir.
Okay. Now I'll just talk of a simple example. Little it is little you have already done this example. That is why I'm doing it. So you have a spinning platform. A person is spinning, standing on it, and he is having some weights in his hands. So what happens to the angular velocity of the platform as it pulls in the weights? If you
Sir,
bring
can you repeat? Sir, can you repeat?
so there is a spinning platform, rotating platform. A person is standing on it, okay, and he is having some weights in his hands,
Okay, sir.
and he throws those weights inside.
सर आई
Then what
डिक्रीज हो
happens to the
जाएगा
angular velocity of the platform?
So it increases.
सर इंक्रीज हो जाएगी सर
Increase हो जाएगी.
ओमेगा को इंक्रीज होने क्योंकि सर एल को सेम रखना है एंड आई ओमेगा तो ओमेगा को इंक्रीज होना पड़ेगा.
You see, I will tell you what is conservation of angular momentum in the next class. So angular momentum is conserved. This you assume is zero because his center of mass is at the axis of rotation. So his center of mass is not having any velocity. Now you see that he starts spinning at a greater angular velocity. Why does that happen? Because L is constant and L is equal to I omega. Since I has reduced when he pulled in the weights, so omega has to increase. Okay, the angular velocity has increased to maintain the same angular momentum. All right, but because the angular momentum is conserved here and angular velocity has increased, so kinetic energy has increased. So why did kinetic energy increase? That is my question.
सर ओमेगा तो इंक्रीज हो गया सर एल इज सेम बट ओमेगा इज इंक्रीजिंग
So, but any physical reason?
What sir?
Who did the work to increase the kinetic energy of the body?
Sir, omega. The person who are pushing.
No,
The
sir, the
weights
person who pulled the weight inside.
So he pulled the weight inside. During that process, he did some work.
Yes, sir.
So he expended his internal chemical energy that was used in pulling the weights inside. That got converted into rotational kinetic energy. Achha, what happens to the kinetic energy of the person till the shoulders? Okay, we will carry on later on. Have you read Feynman's lectures in physics? Some people study it in 12th standard. So Feynman's lectures in physics, he deals with this problem also. If you look at the chapter on rotational kinematics. So we'll carry on with it in the next class. So class is over.
So
Okay, thank you, sir.
upload PDFs and PDFs and videos on Classroom.
You want the actually what I can do is I can share the recording because
So-
making the screenshots is very hard.
Like so, we are writing some notes, but some things we are missed.
Yeah. So I'm telling you, I will share the recording. So when you play the recording, you try to take screenshots.
Okay, sir.
Sir, also please share the previous recordings.
Yeah.
Sir,
So please share the recordings for the previous 2 lectures also, for the last class and the last to last class as well.
Yeah. I will do that.